What's up, guys? It's Talha here again today, and today we are going to talk about some topics in programming fundamentals and a topic in calculus, what we learned at the university today. So, firstly, the first topic we are going to discuss will be about global and local scope, or you can say, the topic is just the scope of the variable, scope of sorry, scope, not a scope the of the variable, scope of the identifier. Well, there's a difference between an identifier and a variable. Identifier is any name you give to, identifier is used to identify, or is used to give any name. When you give any name to a variable, to a function, to anything, that is known as identifier. But a variable is uh, uh, a variable is a thing in a program that changes with respect to time and with respect to your manipulation. So there's a difference between a variable and identifier. This and secondly, uh, we are going to discuss about derivative if we have time. If we are done with this with our first topic in time, then we are going to discuss the derivative. Uh, just the definition of the derivative and the formula which is used to calculate the derivative of the functions. So let's come to our first topic, that is scope of an identifier. So what is scope? Scope means the effect. Scope means effect. So, or in the programming language, you can say the scope of an identifier is the region. Scope of an identifier is the region where an identifier is accessible, or where the or you can also say where an identifier is visible, or where the effect of identifier can be felt, or in the programming language terms, you can say where an identifier is accessible. So in when we talk about scope, we talk about two terms. We need to know two terms in C++ and in, I think, in any other language. One, you have global scope. So global scope means that it has a global scope, means that it can be used, the effect or the accessibility of an identifier like an identifier is available in everywhere in the program. So you can use an identifier anywhere in the program when it has a global scope. So anywhere within that program, anywhere in the program. So it has a global scope. Its accessibility is everywhere in the program. But a local scope, a local scope means that it has a local scope within a block. It can only be it's only accessible within the block it is initialized in. So it is accessible only within a block, where it is declared and initialized, and it cannot be accessed anywhere else except within that block. The scope of a local the local scope of an identifier starts where the identifier is declared, and ends with the closing brace. And you can create different separate sections or separate blocks inside your code in C++ by just adding a brace before the code and after the code, so that section will be considered as a separate block inside your code. And once you declare an identifier, a local identifier which has a local scope right here, for example, so its scope is from where it's declared and up till the end of the block, up till the end of that block in which it is declared. So for global scope, of an identifier. What you do, so you declare an identifier on at the top of your or the after your after your function main. So for example, you have a code, you have hash include, iostream, hash include iostream, and then then you have using name std and all of the stuff. Then you have int main, and you start your program. Here it is, return 0. So let me give you guys an example of what is a local scope and what is a global scope. So for example, we have here we declare, or here we don't declare. I am just giving you guys an example. So for example, here we initialize a for loop, and I declare int I inside the for loop, I equals 0, and semicolon when I is less than or equal to 5. You have I plus plus. This is the example the teacher gave us today in the lecture. So here this is the for loop. Here I see out I every time this loop is executed, and then after that I again see out I. So what is the value of I here after the for loop? What is the value of I going to be after this for loop is all executed, when I see out, or when I output I here? Well, this program is going to give you an error because the identifier I is declared inside the for loop, and its scope starts from where the for loop is started, from right here, and up till right here at the point where the for loop is ended. So it has a local scope inside this for loop, and it cannot be used outside the for loop because it has a local scope. If you wanted to use I or if you want to use I outside the for loop, you have got to declare I outside the for loop. So you have got to write int I here. So you have to declare I here instead of declaring I locally inside the for loop. So this way you will be able to use I anywhere in the program. But if you do it this way, if you declare I inside the for loop, then you will only be able to use I inside this for loop rather than using I everywhere in the program. Also, function names. So function names and your global identifiers have the same scope. Have global scope. Both of these have global scope, given that you define a function and then you place a copy of it, or you place the prototype of that specific function before function main and after a hash include. So both of them and your global identifiers, both of them have have global scope inside the program. Now so for example, there are certain rules which you have to follow when you are working with your local and global scope of the identifiers. So for example, you have a function. For example, you have a function, and or you have a block. For example, you have a separate block right here, and you have and you have a separate variable. So you declare int I here, and and this is a local identifier. This int I is a local identifier, and at the top, this is a separate block inside function main, and in the top after your int main, you have another identifier named int I. So right now you cannot use this identifier inside your program, because these two identifiers have the same these two identifiers have the same entity. These two identifiers have the same identity. So in this block, this local identifier has more effect and is more accessible than your global identifier. So whenever you are going to use the value of this identifier, it's going to give you the value of this local identifier rather than giving you the value of your global identifier. So there's a way you can differentiate between a global and a local identifier, and the way you do that is by using the so this operator is called the scope resolution operator. So what it does, it differentiates between a local and global um, identifier. So for example, if you don't want to use this, I even though it has the same name as the even though this local identifier has the same name as your global identifier, but still you don't want to use this identifier, instead you want to use the global one. So the way to differentiate is by using the scope resolution operator. So for example, if you are to output this C out I, so if you do it like this, it's going to output the value of this local identifier. But if you want to output the value of this global identifier, you have to put this scope resolution operator before it. So that way the compiler will know that it has to output the it has to first find the global identifier that is named I, or that is declared I, and then it is going to output the value of I of the global identifier I, instead of outputting the value of the local identifier I. So this was about local and global scope. And also it's always told that it is better not to use the global identifiers, because when you're for example you're using functions and you use the reference parameter, instead of value returning, or instead of value parameter. And that way, when you use a global identifier, and after executing the function, the value of the identifier is changed. So when you use a global identifier as a reference parameter, the value of the global identifier is changed, and then it is changed throughout the program, and then you're going to get a semantic, and then you're going to get a logical error. And it will be really hard to find where you did wrong or where the mistake was. So it is always better to use local identifiers than global identifiers, because it has a local scope, so it won't affect any other part of the program. But as with the global scope, it will affect every part of the program where a global identifier is used. And also this identifier thing also applies to your functions. So you can also, a function also has a local and global scope, like the variables. A function is also an identifier. So a function is also has a local and global scope, as like your variables. So now we are done with our global and local identifiers. Now let's jump right into our derivative. So what is derivative? The concept of derivative came from this slope. So for example, you have a graph. For example, you have a graph, and the slope of a straight line. How do you calculate the slope of a straight line? So for example, I take a point here, and I take a point here, and so the slope of this line is, the formula is m equals delta y by delta x. So change in y, divided by change in x, divided by change in x, or you can do it this way. So this is going to be the slope. This is going to be the slope of this straight line. You know, it's really easy to find the slope of this straight line because the slope never changes. But what if your graph was like this? If your graph was a curve, for example, if your graph was like this, if your graph was like this, so now what now what is the slope of this curve? You know, because the slope of this curve is going to change at every point, because the line, it's not a straight line. In case of straight line, the slope never changes, but in case of a curve, the slope changes at every point. So what you're going to do, if you take a point right here and right here, so for example, I say this is a, this is a, and this is f of x, the function, and I say that alright, so let's do it like this. Alright, and I say that okay, so now if I now I also take, for example, I take 2 points. So I take here, I take another point here as well. So that will be a, and plus anything, you know, because it's greater. So I add a small bit of anything with a. So it will be a plus h, and it will be f of x, or f of a plus h. So, and now I join the 2 points. Now I'll get a secant line because it's touching at 2 points. But you know what we actually want? We want to find the slope at exactly this point. So the slope of exactly this point, you know how we are going to do that? So we have 2 points. So the slope of this line is equal to the slope of this line. The slope of this line is equal to, you know, if you apply the this formula, so you have, so this point is your a is a plus h, and your b is f of a plus h, and at this point you have a and f of a. So these are your 2 points. So you know, if you want to find the slope, what you're going to do is f of a plus h minus f of a divided by a plus h minus a. So these two will cancel out. You're going to get f of a plus h minus f of a divided by h. Now you know, we want to find the slope at this exact point. So what we assume is that what if this point come nearer and nearer, and you know, eventually it overlaps this point, so it comes closer and closer, and here, you know, this h, so this h, so what we are actually trying to say that what if we apply limit and h approaches 0, so when h will approach 0, this whole term is going to overlap, or this whole term is coming closer and closer to a, so this point is also going to come closer and closer to f of a. So when when the limit, so we apply the limit, so when the limit of h will approach to 0, we are going to approximately find the slope at this exact point. And the slope of this exact, you know, these 2 points, you know, when they'll come nearer and nearer, they'll actually give an illusion, or they'll form 1 point from 2 points. And you know, when we will join those 2 points, we'll actually get a tangent line instead of a secant line, and the slope of that tangent line will show us what was the instantaneous slope at this exact point which we wanted to find. So you know, when the limit of h equals approaches to 0, we have f of a plus h minus f of a divided by h. So this is your formula for instantaneous slope, or you know, in mathematical terms you also call it the derivative of a function. So later in the classes, we are going to discuss some examples, and you know, for now I'll take your leave, and I hope you guys got an idea of what are global and local identifiers and some idea about the derivative. Alright guys, thank you very much.